Good morning, sir.
Good morning. Good morning, students. Am I audible?
Yes, sir.
Yes, sir. Good morning.
Okay. So this is a class of railway engineering, professional elective one. So we are in second module, and we have start second or third module. I forgot.
Short model, I guess.
Third, right? Yeah, yeah. We already finished that second module, right? Okay. So in the third module, I already started, right? In the last class. So what we have discussed in the last class? Anyone remember? So basically, third module of railway engineering is all about your geometric design, right? So, and we have started from alignment, if I am not wrong, right? So we have discussed about ideal alignment or safe alignment, and significance or characteristics of an ideal alignment, and how to provide an railway alignment, and what are the factors that may affect in deciding the proper and safe, comfortable alignment for a railway, and it should be economical. So there are different aspects that we need to consider before fixing a railway alignment. I think these things are already discussed in last class. I hope you have gone through the particular class notes and also the recording, and also you can refer textbooks. Always tell you that please go through textbooks. Fine. So today we are going to discuss about one of the most important parameter of railway gradient or railway profile, that is gradient. Fine. So in this class we're going to discuss about, wait, Let me share my screen. My screen is visible, right?
Yes, sir.
So we are going to discuss about railway gradient. So railway gradient. So if you for some time just ignore the term railway, just concentrate on the term gradient. So what do you mean by this gradient? Anyone? I think in previous semester you have got these things when it comes to highway engineering. So do you have any knowledge about gradient? What do you mean by gradient of anything? Forget about railway for now. Just gradient. What do you mean a gradient? Do you have any idea? And how it is represented and where it is needed? Anyone? Okay, so basically, gradient is required to connect 2 points, higher and lower, basically. Fine. So in a very general and unofficial statement is what? The gradient is a particular tool. Using that, we can connect 2 points located at higher and lower point. That means connecting lower to higher or higher to lower point. How can you connect? This is using by providing gradient. Okay. So basically, if I just before going a very basic definition of gradient, okay, it may be a railway gradient or highway gradient. Okay. Suppose there is a hill. Uh, Let me check. Give you. Sorry. Yeah. Suppose this is a hill. Okay. Now if we are talking about railway engineering, so let's go for the railway engineering only. Suppose this is your rail, okay, railway, geography, okay, art geography, or you can say, suppose in this direction you need to go for providing a railway track. That means before that you have to go for fixing the railway alignment, right? So in designing the railway alignment, if this kind of hilly area, that means rising grade, rising slope, okay, decreasing slope, suppose here again it will go decrease again, okay. So in this area if you want to go for providing a railway track, okay, so there is a to maintain, okay, or again I'll just do, okay, one more time, let me check, okay, wait. Suppose like this, okay, forget about this. Yeah, so suppose your train, you need to provide railway track in this direction, okay. So our based on the previous class, you already know that what is the ideal alignment. It is a straight alignment is considered as an ideal alignment, right? That means if you go through virtually, that means your ideal alignment should be go like this, isn't it? Your perfect alignment should be like this. That means you are meant to provide a railway track in a straight path, okay. But to provide this straight path, what do we need to do? You need to go for, first of all, you need to go for first fill up this soil, because you can see there is a depression, right? You need to fill up this soil, and for this, what do you need to do? You need to cut this soil from this part. You need to cut this soil from this part. You need to cut. We don't need this. Got my point, na? That means to provide a straight path for railway alignment, you need to for this kind of situation, you need to go for first fill up this soil up to this level, and since this soil is below this straight line, and for this part the soil should be cut out. Okay, that means there must be some extra cost may be added in that particular project if you go for this fill up or excavation work. Got it? In that part, in that case, to simplify the or minimize the cost and for smooth or effective movement of the railway train over a railway, you can use railway gradient. Okay, that means you can provide a railway track even if I give different, let me check different color. Okay, you can also provide your railway line along this. This is a railway line, okay, like this. But what is the exact amount of or exact amount of slope that need to provide, which is that will be your railway gradient. Basically, gradient is what? It is the slope from slope of the gradient or slope of the higher elevation from the horizontal. This is the slope, and this is your basically gradient. Okay, if I go for basic geometry, that means for what, suppose for 1 meter of horizontal axis, what is the amount of vertical elevation should be given? Okay, suppose I'm giving you for each 10 meter of horizontal run, suppose 1 meter we are providing vertical. Okay, so for next for next 10, that means counting like this, it will be 2, like that. Like, so if you connect all these points, you will get kind of gradient. So above this you can put or you can place your rail or train. Okay, you can put your train like here. So this is the value, the mathematical representation of or rising, the amount of rising with respect to some amount of horizontal run, that is your gradient. And why this, you can, what you can do, by you can connect the lower gradient, lower point to higher point. Got it? Clear? So this is basically about gradient. Okay, now let me give you a general definition of gradient. So basically, what is gradient? Gradient, I'll just put my class notes. Okay, so basically what is gradient? Gradient is a longitudinal slope basically. Okay, gradient is a longitudinal slope provided along a railway track. So gradient basically it is provided to negotiate the rise and fall in the level of railway track. Okay, so don't confuse with gradient and camber. Okay, so basically what is gradient? Gradient is a longitudinal slope, and what is camber? Camber is your transverse slope provided in a highway. Okay, got it? So these are the direction of the providing slope is different direction. Okay, but they are both are slope only. Camber is also slope, but basically camber is related to highway only. Okay, but camber and gradient both are basically defined slope. Okay, but camber is your uh, transverse slope, but that means across the highway it is provided, not in the longitudinal direction. Okay, but your gradient, the gradient is provided along the railway line, or you can say along longitudinal direction. So we can say gradient is your it is not given here, gradient is your longitudinal slope. Okay, I'll just write here. Here I'll write it. So railway gradient is what? It's a longitudinal, longitudinal slope. Okay, clear up to this? Any doubt? Huh? Up to this, any doubt?
Sir, no, sir.
No, na?
Sir.
I think it is
No,
very
sir.
basic thing that I think you have already got. Okay, but in railway, when it comes to railway, there are uh, four types of slopes can be of gradient actually. Four types of gradient can be provided. Four types of gradient are provided. We are talking about Indian Railway, okay? So four types of gradients are provided. So we are going to discuss about this each and every gradient, okay? In which area, in which place, like this kind of different type of gradient can be provided. First of all, let me just give you. Okay, before that, gradient is represent in terms of what? Like 1 in n. Okay, so this is a representation of gradient. 1 in n means what? For n represents the run, longitudinal run, and n, 1 represent actually the rise. Okay, that means for n number of or n unit of run, we provide 1 unit of rise. So it will be your, this is your gradient. Okay, so it will be your slope, this is your gradient. Okay, so 1 in n, it is the representation of gradient. Okay, and it is the symbol used for gradient is suppose small g and capital N can be used. Okay, you can also check your reference book, textbooks. There may be some one common symbol will be used, so just go through the symbol. Okay, but symbol may be different, but basic concept you have to know. Anyway, okay, so basically gradient are provided to meet the following objective. What are the main purpose of gradient? To reach various station at different elevation. That means in hilly area, suppose to connect two different stations which is are located in rise topmost point or lower point. Okay, in especially hilly area, mainly we are generally talking about the area like Uttarakhand or even in the northeast India, it is a hilly area, right? So here gradient is very important parameter. So to connect two stations at different elevation, to follow the natural contour of the ground to the extent possible. That means natural contour means we are not going any additional cutting of the soil or refilling the soil, art filling. We're not going that. We are just using that natural geography of the earth. Okay, and by doing this also we can reduce the cost of the artwork. Of course, I already told you, if you go for filling the art or excavating the art, it will come with very high cost. So by just providing gradient, first of all you are using just simple normal natural contour of ground, and you are not using art filling or art cutting, so cost will be reduced. So there are some, you can say, the purpose or you can say the advantage of providing gradient. Okay, so now there are mainly four types of gradient may be used in railway engineering: ruling gradient, pusher or helper gradient, momentum gradient, and gradient at station yard. Or generally you can also get uh, it is also known as minimum gradient. Okay, minimum gradient, minimum gradient, minimum gradient. Okay, so first of all we are going to discuss about in this particular notes, it is already informations are provided here, but I will not go through one by one line in this notes. I'll just make you understand what is all this mean. That means what are all these basic definition of that. Then you can also go through this class notes, then it will very easy to understand. Okay, so the first gradient that we are going to discuss about, that one, the minimum gradient, or you can say the gradient in station yard. Why it is called gradient in station yard? Basically this minimum gradient, it is provided in the station only. That's why it's called gradient in station yard. Anyway, we're going to discuss about that. So after minimum gradient, we'll discuss about ruling gradient. Okay, After it, we're going to discuss about momentum gradient, and then we're going to discuss about pusher gradient and or helper gradient. Why I am not following in this form, you will understand very soon. Okay, fine. So we're going to start from gradient at whatever okay, gradient in stationary or minimum gradient. Okay. So gradient in station yard, or you can say the minimum gradient. So basically, in station, I think everyone have gone, visit railway station, of course. So if you just try to get back your memory about railway station, especially about the station yard. That means the railway track, where the railway tracks are provided. All the different tracks will be provided, right? Just try to memorize these things. Okay, just visualize. So in that place, I think you all have seen. Um, I'll just show you in the diagram only here. Okay. Suppose this is a railway track in a station yard. Okay, like this is a one railway track. This is your second. Okay, so it's like this. There are third. Okay, so this is I'm talking about a railway station only. Okay, so in some railway station, uh, in some places, one water line will be connected like that. Pipeline, water pipe or water distribution line will be connected like this. Means it is little bit underground, and here also. And this from this water pipe, this water supply will be provided to each train, which is you know connected like that. These are the water pipe from here also, like that. I think you have seen, right? In some railway station, the water pipe is provided by side, like that. Huge water pipe will be provided. From there, uh, water is connected for supply. Got it? I think you have seen this thing, right? So I'll show you one picture if I have. Let me check whether it is have or not. Railway station. Hmm. Let's check. Oh, sorry. Let's see some images of railway station whether it is can be seen or not. I think here it is showing little. Okay, can you see here? Let me show you a bigger picture. Okay, is it visible here? That part? I'll show you like that. This part. I'm talking
Yes,
about this
sir.
part. Is it visible, right? Can you see?
Yes, sir.
Okay. So this pipeline, basically this water pipeline is provided for what purpose? Suppose one train will come in this track, then for water supply into the railways, this train, it is provided by this pipeline. Okay, and additional work of this pipeline is what? To wash out the waste from this railway yard. Okay, that means using this water pressure water supply system, a frequent maintenance, or that means washing of that railway yard will be go on. Okay, and if you go for regular washing of the railway track or railway yard, and if your this part from here to suppose here is your railway station, suppose this is a complete horizontal normal plane, then what will happen? Water will be stuck here, right? That means you also need a proper drainage system in railway station, correct? So to provide the railways to provide a proper drainage system, what the basic thing we need? Gradient, right? Suppose the out for this station, I'm just giving a hypothetical. Okay, I am not maybe wrong. Suppose your drainage of this railway station will be in this direction. drainage point will be in this direction. It means wastewater will need to go in this direction. So what we need to provide, that means we need to provide this point will be little higher than this point, correct? For providing this higher elevation or to providing this thing, that means what? We are providing a gradient in railway station. This is actually defined as a minimum gradient, or you can say the gradient provided in station yard. The main purpose of that, to drain out the water. Clear? So basically, what is the definition of that one, your minimum gradient? So minimum gradient is the gradient which is provided in the station yard. It is the minimum value of gradient provided at station yard in order to maintain effective drainage. Okay? So to maintain effective drainage, we can provide a gradient in station yard to maintain effective drainage. Effective drainage in station yard. I think it is clear, right? Okay. So to maintain the effective drainage in station yard, a particular amount of gradient is provided. Okay, in station yard. Okay. So basically, how much provided? Generally, you can say it is provided as 0.1 percentage. Okay. So what is the amount of gradient, or minimum gradient is provided in station yard, like 0.1 percentage. It is also represent like what? It is also represented by 1 divided by, if you give in the ratio 1 divided by, it will be 1000, right? Then it will come 0.1%. Okay, and it should not be more than, that is 0.1. It is the generally it is provided and should not be more than 0.25%. You can also cross check with your reference book. Okay, if I'm not, please also you can also tell me, okay, about that if I'm wrong. So for now, this is the value. You can also cross check. So this is the minimum value, and this is your 0.1%, the minimum gradient, and it should not be more than 0.25%. Okay, it can be given as, if I give you in the ratio 1 by 400, like that. So this is all about gradient at station yard, or minimum gradient. Okay, clear? So next one, suppose I'm going to discuss about your ruling gradient. So I don't think all gradient will be discussed can be possible. So we can also continue in the next class. Anyway, well, let's go. So let's discuss about ruling gradient. So basically, what is ruling gradient? So basically, while operating on this gradient, that means I'm talking about ruling gradient. Okay. So while operating on this ruling gradient, we don't need to provide any additional engine power. Okay. And therefore, ruling gradient is that value of gradient which allows to operate with the same engine power effectively. Now, actually, definition is how to understand this definition. So let me explain you by, again, a graphical thing. So fine. Okay. So suppose, let me use this color. Okay. Suppose this is a simple horizontal ground level. Okay. Again, let me give you a straight line. Let me draw a straight line. Very difficult to draw with mouse. Okay, anyway, suppose this is your general ground surface. Okay, very horizontal. Okay, now when it comes to, we already discussed about gradient at station yard, or you can say the ruling gradient. Okay, suppose this is your out, the station need to move in this direction. Okay, this is the direction of the movement. Okay, anyway, this, the train can be moving along all both direction. Anyway, for understanding, let's assume that the station should be go in this direction. Okay, now this is a horizontal line, hypothetical. Okay, this is a very hypothetical thing. Okay, so we are already discussed about minimum gradient. So minimum gradient is little bit higher than this thing, right? Higher than natural ground surface. So suppose this is your gradient. This is your suppose minimum gradient or standard gradient, whatever you say. Okay, minimum gradient. Okay, okay. So just imagine one train. To understand this ruling gradient, basically, suppose this is our horizontal line. Suppose there is a train. Okay, I'll just draw a train line. Let me take red color now. Suppose this is a train. Okay, this is a train. So with this train connected with some engine, connected with some wagon, and this is your engine part. Okay, so this train can move or can travel along this horizontal line easily. Okay, or you can, in other words, you can say this locomotive can carry the wagon attached to it along this line. Now, if I increase the line of directional movement little bit higher elevation, suppose this elevation I provided. Now this train need to move along this line. Suppose this is a train and wagon is also connected. Okay, so same train. Suppose even this train also can move along this line with the same engine. That means this locomotive can carry the wagon even in this gradient. Okay, now let's again increase the gradient. Suppose up to this level. Up to this level, we have increased the gradient. Okay, now let's give new line above this. Okay, now let's try whether our train can move along this track with the same engine power or not. Okay, now from suppose experiment you got it that this train can also, it can also move along uh, this line easily. That means without additional power or with the same engine power, it can move along this line. Okay, so next again let's repeat this thing. Again we go for, let's again we rise this line up to this point. Again we draw, suppose this is a new railway line, railway track. Okay, now if you suppose here again we'll try whether our train can move along this line or not. Okay, now from experiment it is seen that the train cannot move along this line. It is not, that means suppose up to this point it can move, then it will not going to carry, it will fail to move along this line. Fine. From this point, what we can say that this train can only move up to this elevation, this one. I'm talking about this one. I'm talking about this up to this gradient smoothly without additional engine power. Okay, with this, that means up to this gradient, line, the train can move smoothly. So basically, this is your ruling gradient. Okay, that means above ruling gradient, if you're providing any railway track, that means in that particular case the train cannot move. Okay, so we can say ruling gradient is a maximum gradient that can be provided along the railway track. Okay, up to which a train can travel, or a locomotive can carry the wagon without additional or external force, with the same engine power can move. So this is basically about ruling gradient. Okay, so about the definition, what is basically the ruling gradient? We already discussed, right? Again, I'm going to repeat. So while operating on this gradient, that means while operating in the ruling gradient, we don't need to provide any additional engine power. That means the same engine or same locomotive can move or can carry the wagons in the ruling gradient without any additional engine power. Therefore, ruling gradient is that value of gradient which allows you to operate with the same engine power effectively. That means with the same engine power, uh, it can be moved along this ruling gradient. Okay. Now, from this point, we can say this ruling gradient, suppose this ruling gradient is always higher than your minimum gradient. Now, have you understand this thing? Up to this, ruling gradient is higher than minimum gradient. Okay. Now, in some exam, it may come like, okay, that's suppose I'm giving you the amount of ruling gradient provided. This ruling gradient, sorry, yeah, or we can say another term, that's minimum gradient. The first one that we have already discussed, the minimum gradient which is provided in stationery, the amount of minimum gradient is always greater than 0, but less than ruling gradient. Ruling gradient. It is clear? Minimum gradient is always greater than 0, but always less than ruling gradient. Or in other words, you can also say ruling gradient is greater than minimum gradient. Clear? Is it clear?
Yes, sir.
Okay. So anyway, up to this point, I think if it is clear, then I just want to close for class, because we are not going to complete this all these things. So in this class, up to this, we have already discussed about what is gradient, the basic definition of gradient. Okay, what is the purpose of gradient, what is the advantage of gradient, and we have also discussed about different types of gradient like minimum gradient, ruling gradient, pusher gradient, and momentum gradient. Okay, so specifically in this class, we have discussed about what is minimum gradient and what is ruling gradient and what is the amount of ruling gradient. Let me check whether yeah, you also you can take the note here, the amount of ruling gradient. So let me draw here only the ruling gradient. Basically, for hilly area, highly hilly, I can say, for competitive exam it will be good for you. For hilly area, what is the, yeah, for hilly area, for hilly area. So the amount of ruling gradient is basically given as 0.6721 percentage. In other words, it can be given like the ruling gradient for hilly area ranges from 1 by 150 to 1 by 100. Okay, the same thing, 150 means 0.76 like that. And for plain area, if you want to go for providing ruling gradient, so it will be from 0.5 to 0.5 to 0.5 to 0.67. So in plain area, a lesser amount of gradient is required in percentage. Okay. So in fraction, it will be 1 by 200 to 150. 150. Okay. So you will get this thing. Even in the if it is not in the notes, then you just go to the class recording. From there, you can also collect this. Okay. So for now, these things we need to understand. In the next class, we're going to discuss about the momentum gradient and pusher gradient. Okay. Okay. So let me. Is there any doubt? Do you have any doubt till now? Where it go? Is there any doubt? अगर डाउट नहीं है तो just I'll just close my recording, then we'll take your attendance. ठीक है? ठीक है. So I'm stopping my recording now.